Hey, so I wanted to record this video to kind of help those of you that are ready to start solving equations, and then when people are ready, we can have these tools in place. So this is kind of be like your notes or your foundation for solving equations. And so to jump in, let's write down some basic steps that we're going to consider here when we look at this. So the first thing we're going to say to ourselves is, let's look for, to start off any problem, is that we always want to look at each side of the equation. So on either side of the equation, you want to look to see if you see any distributive property. Oops, sorry about that. So let's see if there's any distributive property that you can take care of. And so remember, distributive property is going to be a situation where you have the parentheses that's being multiplied by something on the outside. So we say to ourselves, oh yeah, we do. So check this out. We've got the 2 times the x. So we got the 2x. And then we have the 2 times the 5. And so that would be plus 10. Right? So remember, distributive property is something that looks like you've got a number on the outside that's being multiplied by numbers on the inside. And so that would be a times b plus a times c. All right. The next thing we would look for is we'd look for combining any like terms. So once again, this would be on the same side of the equation. So we're looking at, so we're saying, are there any like terms? So we'd look for combining like terms. And once again, this is on the same side of the equal sign. So on the left-hand side over here or on the right-hand side over there. So we go ahead and we jump into this. And my bad, I forgot to bring down our previous thing. So once we do this distributive property, we need to bring down the things that we haven't used yet. So we haven't used the plus 3x and we haven't used the 20. So we're regrouping what we have here. Now, at this point, I want you to act like you don't see that anymore. You've already used that. It's done. You don't have to cross it off, but you're just like saying, I'm done with that. So now we go on to saying to ourselves, are there any like terms? When I look at the left-hand side, I see that I have a 2x and a 3x. And I can put those together. So a positive 2 plus 3, that would give me 5x. And then once again, I'm going to bring down the things I haven't used. So this is gone, this is gone. We put those together, we get 5x. We bring down the plus 10 equals 20. So what we've done in that step is we've combined the terms that are alike on one side of the equation. At this point, what we're going to do is we're going to look to see if we can use, now we're going to start moving things across the equal sign. So now we're going to start using inverse operations. So we're going to use addition / subtraction to move variables and constants across the equal sign. And basically this is going to be using inverse operations. Because remember that once we move things, when we start moving things across the equal sign, that's when we start seeing these, seeing the inverse operations need to be used. Now remember, this is that situation now where what you've done in the past is you draw this little line right here. So you're trying to move things across the line or the equal sign. And so you can remember in class, I talk about not using that line, but there's nothing wrong with it. You're welcome to put it on there. Okay? And I'll model that the first time around. But what we want to do is use addition or subtraction to move variables and constants. So when I look at the left-hand side right here, I see that I have a 5x plus 10 equals 20. Well, I'm not going to move the 20 because it's already by itself. What we're really trying to do in this step is we're trying to isolate. We're trying to isolate what's called the constants and the variables. So 10 is a constant because it doesn't have a variable on it. It doesn't change. It's always going to be 10. 20 is a constant because it's always going to be 20. 5x is obviously has a variable in it. So it's not constant because if x is equal to 1, then this is equal to 5. If x is equal to 2, then this is equal to 10. If x is equal to 3, then that's equal to 15. So that's not a constant term. It's not always going to be the same. So back to what we're doing, we're going to use addition or subtraction to move variables or constants to get them all to one side. So in this case right here, since I want to move this 10 over here with the 20, Well, using inverse operations, the opposite of a positive is to be a negative. So we subtract 20 here, we subtract 20 here. So now what's happening is I've gone from working this problem kind of horizontally to, once again, I'm not looking at this line anymore. I'm only looking at like what's right here. And so I come back to the left-hand side and I say, okay, well, I've got this 5x, and that 5x is, it has no like terms, nothing to put it with. So I'm just going to write down 5x. I'm just going to bring that guy down. But I look at the tens, and now I have a positive 10 and a negative 10. Well, technically those tens cancel each other. They give you 0. I bring down my equal sign. And then on the right-hand side, I say, okay, well, what would be 20 take away 10? And the answer is 10. So step 3 is I've used addition or subtraction to move all of my variables and all my constants to one side. And that can be multiple steps. I might do that more than once. So here I am, once again, I'm not looking at these things. I'm done with that. So I'm only looking at this piece right here. Most of you are going to be able to say, oh, Mr. Fix, the answer is 2. But why is it 2? Well, it's 2 because now we're going to use multiplication or division to isolate the variable. Isolate means to get it by itself. So right now, this variable has a times 5, right? That's understood to be multiplication. It's got a times 5. Well, the opposite of multiplying is to divide. So we're either going to use multiplication or division to isolate that variable. So I cancel on that side. The 5s cancel. If you do something to one side of an equation, you got to do the same thing to the other side. And so here I am sitting with my final answer of, and we'll go back to red because that'll show us that we started in one color and ended in the same color. On this side, I'm left with x. I bring down my equal sign is equal to 2, and that would be my solution. If I wanted to check that, I could come back up to the beginning and I could plug it in to test it to see how that works. So I would say is 2, I'd plug in my 2 for x, so 2 for x, plus 5, plus 3 times 2, is that equal to 20? And so I plug that in real quickly, that's going to be 7, 7 times 2 is 14, plus 3 times 2 is 6, and sure enough, 20 equals 20, so I've found my solution, and this is my check. Okay, and that's just a kind of reminder. What this video is really about is like the process of solving an equation. All right, I'm going to go ahead and apply this again to the second problem here that we see on the screen. So we're going to start off with the distributive property. So I've already got my red pen, so distributive property. I look at the left side of the equation. There's no distributive property over here. But on this side, there is. So I go ahead and distribute. So that gives me negative 2y. And I take negative 2 times positive 10. That gives me a negative 20. Okay, so some of us may still be grappling with why is that minus 20, but I said negative 20. All right, keep playing with that. And I bring everything else down. So I bring down, I didn't use the 6y, so I bring it down. I didn't use the 12, so I bring it down, and I bring down my equal sign. All right, at this point, the interesting thing is that we look at the next step, which is combining like terms. There are no like terms. So when I look at this side of the equation right here, so I'm just going to go ahead and circle that. When I look at this side of the equation right here, there are no like terms. I can't put 6y and 12 together. And when I look at this side of the equation, there are no like terms. There's nothing I can put together. The negative 2y and the negative 20 don't go together. So I can't undo. That's a bummer. All right, we'll just leave the circles there for now. Sorry about that. Clear selection? No, that'll clear the whole screen. So at that point, there's nothing to do on step 2. So I go to step 3, which is use addition or subtraction to move the variables and constants to the same side. So this is kind of like where like your number sense will develop. I want to move all the y's over here, and I'll move all the constants over there, or vice versa. It doesn't really matter which way you do it. You can move all the constants. You can move the negative 20 over here, or you can move the positive 6 over there. It really doesn't matter how you do it. However, I do know one thing, and I do know that in this case, if I add 2, so the opposite of subtracting 2 is to add 2. So I add 2y to this side. If I do that to that side of the equation and I do it over here, then what happens is I kind of put myself in this nice situation where I don't have any negatives. on that. So let me slow down here and back up. So I got my 2y set up to simplify, to move them to one side. I want to remind you that we read a book from left to right. So once I do that, I come back to the left-hand side and I say, okay, well, let's combine like terms. So I've got 6y plus 2y. That gives me 8y. I haven't used the 12, so I bring that down. So that guy comes down, so plus 12. The equal sign always comes down. Right here, I have a negative 2y and a positive 2y. Those guys actually cancel. And then the negative 20 or the minus 20, I haven't used it, so I bring it down. All right, so remember at this point, I'm no longer looking at the first step. I've done this process of using inverse operations on the green step right here to move my variables all to one side. So I'm no longer looking at this guy anymore. I'm done with that. Now here I am, I'm still on the green step because I still have some numbers, some constants that need to be moved to the same side. So once again, I read a book from left to right. I come back to the left and I'm like, all right, there's no more y, so I'm good with 8y. I leave that there. But wait, I need to move this 12 over here with the 20 because I need to move all the constants over. So I go ahead and write minus 12 because the opposite of adding 12 is subtract 12. If I do that to one side of the equal sign, I have to do the same thing to the other side of the equal sign. Now remember, this is this conversation where in the past, you probably had this line going down your paper like this. And that line represented like this idea of one side or the other side. If that helps you, please continue to do that. But for our problem right now, we're in a situation where we are going to go back to the left-hand side and we're going to say, okay, well, let's simplify. Let's combine the things that we've done. Well, the 8y has no one to go with, so I just bring the 8y down. All right, the 12s, I have a positive 12 and a negative 12, so those guys just cancel. I always bring down my equal sign, and I pull out my calculator, or I do the math in my head, and I realize that negative 20 take away 12 will give me negative 32. Once again, I read a book from left to right. I come back to the left-hand side, and I say, do I have any more addition or subtraction that I can use to move things, from move constants to one side and variables to the other side? And the answer is no, because at this point, all of my y's are on one side, and all my constants are on the other side. So I'm on to the purple step. I'm ready to isolate my variable. I'm ready to get y by itself. So recall that's 8 times y. The inverse of multiplying is to divide. So the benefit of that is now the 8s are going to cancel. If I do this to one side, I must do the same thing to the other side. At that point, we simplify. We come back to the left-hand side. The 8s have canceled, and I apologize, I'm a little bit out of room. So I get y equals, and then negative 32 divided by 8 would be equal to negative 4. Once again, you can do a check on that. You can plug that in. All right, we're going to stop the video right there. What I want you to do is I want you to use this video to kind of at least knock down the first boundaries, or knock down the first situation to these problems. All right. What I'm going to do is I'm just going to hit pause real quickly. I'll pull up a different problem, and then we'll take a look at a little bit easier scenario. All right. So kind of now you say, okay, this is like the hardest one. What would an easier one look like?